Hey guys, today's lesson is 5.5 Graphs of Relations, and this lesson is all about your X and Y values. So we're going to start by going over domain and range, and then we're going to look at how to calculate X values when given Y values and Y values when given X values. So let's get into it. Okay, so the first thing to remember is if you're trying to determine if a graph is a function or not, you can always use the vertical line test, where you just draw vertical lines through the graph, and no point on the graph can touch a vertical line, or no vertical line can touch more than one point on the graph. So yeah, no 2 points can share the same X value. So we've talked about domain and range before. Again, domain is all of your X values, range is all of your Y values. But we haven't really been writing them out mathematically, we've just kind of been listing them. So today we're going to show you how to actually write out the domain and range mathematically, and we use something called set builder's notation to do this, which is where you write using inequalities. So just a reminder from grade 9, if you have like an open dot like this, you use just greater than or less than signs. If you have a closed dot like this one, you use signs that are either greater than / greater or equal to, or less than or equal to. And then if you see an arrow, that means it just goes on forever. It's kind of like we'll see infinity. So let's look at what this would actually look like. So this is the first graph that we have here. For domain, we're going to start by just kind of writing out the X values that fall within this graph. So when we're looking at X values, we're looking at the width of the graph, essentially, like how far across it goes. So we're going to start by reading off our lowest value on our x-axis. So this is the furthest to the left our graph goes, and that point is at -1. So -1 is going to be our smallest domain value. And then we'll go as far to the right as the graph goes and read that x value, which is 3. Then we're going to put our x in the middle, because all of our x values are going to fall somewhere between -1 and 3. We don't have any x values outside of that range. Then we have to figure out what symbols we're going to put between the x and our numbers, and they can be any of these 4 symbols: greater than, less than, greater than or equal to, less than or equal to. So because all of the x values in this graph are above -1, that means that our x is going to be greater than -1. Because if I pick any point on this graph, the x value is going to be above -1. And because this is a closed-in dot here, I can put or equal to. And then if I compare the x to the 3, well, all of the x values in this graph are below 3. So x is less than 3. And because this dot is closed, I can write or equal to. So that is how we use our inequalities to represent domain. And then we have to add something called set builder's notation, which looks like this. The domain is a set of x values such that x is between -1 and 3. And then at the end, we just put, and x is a real number. Okay, so that is how you have to write out your domain. So this little squiggly line here just means that the domain is a set of. So it is a set of The X just means X values, and this line means such that. So the domain is a set of X values such that, then we have our inequality, and then at the end we say X is a real number. Sorry, this is the word is. Okay, you should also check these two signs. Don't have to be identical, but they do have to face the same way. If they don't face the same way, you've done something wrong. Okay, and then we're going to do the same kind of thing for our range, but now our range is looking at our y values, so it's looking at the height of our graph. So we're going to start with our lowest value anywhere on the graph. Our lowest value is going to be -2. And then our highest value anywhere on the graph is this point here, which is at a 2. And then again, we're going to put our y in the middle. All of the y values of this graph are above -2, so we're going to say that y is greater than -2. And because our dot is closed, could also equal -2. Then we're going to look at our other variable here. All of the y values in the graph are below 2, so y is less than 2. And because our dot is closed, it could also be equal to 2. And then we're going to finish off our set builder's notation by saying that the range is a set of y values such that y is between -2 and 2, and then y is a real number. Okay, so this front part here, the squiggle, the X, the line, the squiggle, the Y, the line, and the end part, Y is a real number, sorry, X is a real number or Y is a real number, those are never going to change. It's only this part in the middle here that's ever going to change. So let's try another example of this. Okay, this one looks a little bit different. Let's start with our domain again, which is how wide the graph is. We always want to start with our lowest number first. So our lowest number here on our x-axis, the furthest to the left it goes, is -2. And then the furthest to the right that this goes is +2. And x is going to be between them. Now, as long as you have x between two different numbers like this, like we've been doing all along, and we write the smaller number first and then the bigger number, my arrows are always going to point in the same direction because x is going to be bigger than the lowest value and x is going to be less than the greatest value. Because this is an open circle here, we are not going to put the extra line under this greater than sign. However, because this is a solid line that is passing through this point of 2, it's like a colored in dot. So this one we're going to say or equal to. And then we finish off our set builder's notation. So we say that the domain is a set of x values such that x is between -2 and 2, and x is a real number, and then close our squiggly bracket. Now let's try the range. Again, the range is how high or low something goes. In this case, though, the lowest point is actually an arrow. And if you remember from up here, an arrow goes on forever. So this doesn't actually end here, it just keeps going and going and going, which means there is no limit to how low our y values can get. So I'm not even going to put in a lower limit for my y value. I do have an upper limit, however, and that is my 4. I can't go any higher on this graph than a 4. Okay, so then I'm going to put in my y. This time I don't have 2 numbers because, again, one of them doesn't stop. It just goes on forever. I don't have a number that I can associate with this arrow that just keeps dropping. But I do know that all of my y values in this graph are below 4. So y has to be less than 4. And because this is a solid line going through that point on the graph, it could also be equal to 4. Okay, so anytime you see an arrow on a graph, it means that you're not going to have 2 numbers for both your domain and range. Sometimes it might mean that you only have 1 number for both the domain and range. Sometimes you might actually have a domain or range that has no numbers if you've got enough arrows. Okay? So you don't always have to have numbers in your domain and range. But we do always have to put in the rest of our set builders notation. So range is a set of y values such that y is less than or equal to 4, and y is a real number. Okay. Like I said, sometimes you might have no numbers at all. So let's look at what that might look like. Let me just pause this while I draw. Okay, let's say I had something like this. So my domain is, again, how wide this graph is. And assuming this line goes straight up and isn't actually getting wider, assuming this goes straight up, the lowest my number is going to get is -2, and the highest it's going to get is 2. So -2 and 2, my x is going to be between them. All of my x values in there are above -2. They're all below the 2. And then because I don't have any open circles or anything, I can also include my or equal to signs. And then I include the rest of my set builders notation. So the domain is a set of x values such that that is true, x is a real number. This is where it's going to get a little different, is with my range. If I look upwards on the range to try and find the upper limit, I will see that there is no upper limit. And if I look down to try and see what my lower limit will be, well, this arrow tells me there is no lower limit. So I don't have any numbers that are going to limit what this range could be. So instead, I'm just going to say that my range is a set of y values such that y is a real number. I don't have this middle section at all because there's no limit to what my range could be. It goes on infinitely in the positive and in the negative direction. The one thing to watch out for is that if this arrow here was not straight, if instead it was actually getting wider, like that, that would mean that I don't have any limit of my x values in this direction either. Okay, so if this is going straight up, my x values can't get any lower than -2. If it's going on a slight angle like this, well, now my x values can keep getting lower and lower. So I would get rid of that part of my domain if that was the case. Okay, so that's it for writing domain and range. Next, we're going to look at how to actually calculate X and Y values. Okay, so the next thing that we have to do is something called complete the coordinate. Essentially, you'll be given an XY coordinate where you know either your X or Y value and you don't know the other one. Now, if I had a graph to go along with this, I would just read it right off the graph. I would find -3 on the X-axis and go up to find where that would fall on the where that line hits the Y-axis. So it's very easy to just read that off of a graph. But if you don't have a graph and are given an equation instead, you can still solve it like that. So the first thing that I want you to remember is anytime you see this f of x, that really is just the same thing as y. So it might be easier to rewrite this equation that you were given as y equals -3x plus 7. Okay? So I'm just writing my f of x as y. Then I'm going to plug in my known coordinate into either the x or y position. So because coordinates are x, y, this -3 is an x value. So I'm going to plug it in where my x is, and then I just solve from there. So -3 times -3 is 9, and then 9 plus 7 is 16. So my final answer is that the complete coordinate is -3, 16. Let's try it again if it's the other half of the coordinate that you're missing. So this time I'm missing my x value and given my y, if f of x equals 4x minus 3. Again, I'm going to start by rewriting my equation and replacing f of x with y. So y equals 4x minus 3. You don't have to do that step, but I just don't like using f of x. I prefer using y. And then because this is an xy coordinate, the 9 is my y value, so I'll plug that in. And then I have to solve for x. So that means I start by moving my -3 to the other side, and we just use opposite operations. So because this is -3, I add 3 to move it to the other side. What I do to one side, I must do to the other. So 9 plus 3 is 12. And then in order to get the 4 away from the x, I just divide by 4 on both sides, and that leaves me with 3 equals x. So my final answer is 3, 9 as my coordinate. So these are the two steps that you'll follow regardless of which of the two variables you're looking for, whether you're looking for x or y. You always just plug the known variable into the equation. So if it's an x variable that you know, you plug it in where the x is. If it's the y that you know, you plug it in where the y is. And then your second step is to just solve for the unknown variable. That's really easy if you're solving for y. If you're solving for x, you will have to use some opposite operations in order to get the x by itself. Just remember, we always start by moving the things furthest from the x, which is why we moved the -3 first. And then we do our division last. That should always be our very last step. So we divided by the 4 last. Okay, that is it for today's lesson. Make sure you email me if you have any questions.